Problem 5, an electron moving parallel to the x-axis has an initial speed. Okay, first of all, we have x-axis, and we have an electron is moving to the right from this point to this point. Uh, Initially, this point is at the origin. So here we have the origin O, and here let's say we have the point 1. And this electron at O has a velocity equals to 3.7 times 10 power 6 ampere second. VO equals 3.7 times 10 6 ampere second. And this speed reduces at the point 1, it will be V at the point 1 equals to 1.4 times 10 5 m per second. Okay, before let me explain a point. Here we have a negative charge. In order to move this charge from here to here, sure, you have an electric field. This charge cannot move alone. You have to understand this point. So you must have here, let's say we have a negative plate. In the case of negative plate, the negative plate will push this negative charge away. Okay, so in this case we have an electric force applied on this charge, Fe. And also on the charge you have mg. And the charge is moving from O to 1. So we have a displacement between this point and this point. So here we have dx. I ask you to calculate the electric potential difference between the origin and that point. I want to calculate delta V between O and 1. Okay? Okay, here I give you the velocity. I cannot calculate delta V from this relation, E times dx, because I don't have the position of 1 and the coordinates of 0 and 1. I don't know the value of E. So it's impossible to use this relation to calculate delta V. You have to think of another method. Listen, here in general, you know omega total equals to delta kinetic energy. It's the kinetic energy work theorem. The total work applied on the charge, you have mg and Fe. And you know mg is perpendicular to delta x. In this case, omega mg has no effect. Omega mg equals to O, because mg is perpendicular to delta x. So delta omega total equals only to omega Fe. You know, Fe is a conservative force. Fe is a conservative force. And F conservative equals to minus delta potential energy. Excuse me. Omega F conservative equals to minus delta potential energy. So we can write here omega Fe equals to minus delta potential energy. Okay, now we know the relation. We can solve the problem. We can write delta kinetic equals minus delta U. Here you can understand delta kinetic equals to minus delta U, or you can write delta kinetic plus delta U equals to O. So always we have a conservation of mechanical energy. It's the mechanical energy here. Okay, so we can solve, we can say delta U equals to minus delta kinetic equals to minus half mv square final minus m over 2 times v initial square. You know, delta U, you know, we have a relation between delta V and delta U. You know, delta U equals to Q delta V. So we can write here directly Q delta V. So Q delta V equals to minus M over 2. We have the value of V1 and VO equals to minus M over 2 VO okay. Here we can put this one is square. Okay, we have electron, so we must have the mass of the electron, and we have Q of the electron. I give you the value of Q and M, so we can calculate delta V directly. So M of the electron equals 9.11 times 10 power minus 31 kilogram, and the Q of the electron equals to minus 1.6 times 10 power minus 19 coulomb. We put M and Q, we get finally the value of delta V. Delta V equals to minus 38.9 volt. Okay. Now I ask you, which point is at the highest potential? Okay. We can draw. We have the origin, delta V between O and 1 equals to V1 minus VO equals to minus 38.9 volt. If we have a negative value, it means VO has higher value than V1. Okay? So we can say here VO has the higher potential.